In this lecture series, we see about a new topic of finite element analysis. So this is also called as the finite element method. Okay. So let's see on we have introduction about finite element analysis today lecture series, and also we have to move for the different types of methods. Like one dimensional problem, two dimensional problem, heat transfer, and finally we are discussing about CFC, that is computer fluid dynamics. Okay, so it's on the next topic. So first of all, what is the meaning of finite element analysis? So the finite element analysis means the one of the numerical or approximation method of differentiating the equations. That is the foremost thing. Okay. So the finite element analysis we have to simply called as a FME or FMEM. Is a numerical techniques to find the approximation solutions of to the boundary value of the problem for the partial differential equations. In a simple terms, the FEAM is a method is for dividing up various complicated problem into the small element. So in this class, we discussing about what is the meaning of element, what is the meaning of node, what is meaning of mesh. Okay, so how to give a force, how to give a load. Okay, we have to study different types of parameters. Okay, and also we have to solve the reactions up to each other. Okay, and also we can using for the different types of problem with a complicated geometry like a load, material property, whereas the analytical solution cannot be applied. Okay, so we are discussing the different types of features about the finite element analysis. So how does the work finite element analysis? So first of all, the FEA or FMEM are using for only for the complex system of points. So like a node with the make of the grid is called as a mesh. Okay. So the mesh can be divide the element. Okay. So based upon our user interface or user given the value for the mesh, it can be divided according to complex structure. It can be divided the mesh. So that the mesh can be is called as a collection or called a complicated system of points is called as a node. That node can be make the grid. That grid is called as a mesh. Okay. So the mesh is a program to containing the material and the structure properties. Okay. Which define the how the structure will react to certain load condition. So based upon the mesh value, we have to define the accurate value of the given types of materials. Okay. So for example, if you give a any types of material, the based upon your mesh value, only the FMEA is working. So first of all, the node can be assigned. Okay, the mesh how to calculate means the node can be assigned this certain density throughout the material. So what is the shape of your material? Is like a regular or irregular or whatever shape. The material depends upon your anticipate stress level of the particular area. So based upon your stress level area, we have to predict the what is where is the strength, where is the weaker part of the given object. Okay, and also region which will receive the larger amount of stress. So first of all, what is the meaning of stress? The stress can be defined by load by area. That is called as Newton per meter square. Okay, how much of force can be applied the per unit area? That is the meaning of stress. Okay, that is the stress. We can usually having a higher node density than those which experience little or no stress. The point of interest may consist of fracture point of previously tested material or fillets or corner, complex detail, and high stress area. So the mesh act as a spider web. It's like a spider web and is a form of the each nodes. The nodes can be connected in the form of the grid that is called as mesh. That is a extend the mesh element to each of the adjacent node. This web vector is what is the carries the material property to the object, the creating the many elements. So these elements can be analyzing the different methods and different types of node. So here I have to call the simply diagram for understanding purpose only. We are discussing the detail how they generate these types of problem. So in this, if we are discussing the what are types of engineering analysis. So the first of all, we are to discussing the structural analysis. So the structural analysis is called as the consist of linear and non-linear modes. The linear mode is useful parameters and also using the simple parameters assuming the material it is not a plastically deformed. is not a plastically deformed, but a non-linear model is a consist of stressing the material past its elastic capability. The stresses in the material then very rare with the amount of deformations. Okay, so the plastic deformation is not deformation means the is not retain the original position. That is called as a plastic deformations. Okay, after the plastic deformation, the particular material doesn't contact to the original shape. So next, move on the next topic, next types of engineering analysis. That is one of the foremost thing using vibration analysis. Okay, so I have considered the voltage. I have considered here. I have to certain condition load. I have to apply for this case. Okay, so for I have to using the testing the material against the random vibrations, shock, and impact, and each of these incidents may act as a material natural vibration frequency. That is the frequency of the material in terms of many causes like a resonance and a subsequent failure. So what is a resonance? The resonance is a repeated load can be acted at a particular period. That is called as a resonance. It can be acted at a high speed. It is not abnormal speed. It's called abnormal speed in a particular system. We call it as a resonance. Thank you.